Okay, I'm recording the sessions also. Yeah, so what are these assertions and coverages? Why we are going for them? Okay. Coverages I'll explain you later, like what is a coverage, why does we go for it? I'll explain you first the assertions, okay? Excuse me. Assertions is like one way of verifying your design, okay? Coverages also, you are verifying your design. So assertions and coverages both come part of your verification environment, okay? So up to now, like you have seen how to write a verification environment for a particular design, system Verilog environment. Now, in order to find more bugs, if any bugs were hidden that was not showing at the compilation or runtime. Okay, so those type of bugs, some bugs we can't find it also. So we have to check it in other ways. So one of the way to check those bugs is like by writing assertions. Okay. So what are assertions? How will you write is like assertions are primarily used to validate the behavior of your design. Behavior means you will be writing assertions for signals. Okay. For all your input and output signals, you will be writing the assertions. So you are verifying the behavior of that signal. It means whether the signal is behaving correctly or not. Let's say I have a reset signal. So reset signal initially it should be high and after 10 seconds it should be low for your entire simulation. So after 10 seconds it should be low for the entire simulation. In the entire simulation, if again the reset becomes high, you're not mentioning that condition, but due to some delays or due to some external things or external noises, your reset signal has become disturbed and it has gone high. That type of bugs you can't observe. Like you will just simulate it, you will get to know, okay, it was working and it was fine. But you don't know when the signal will go up. We may not give assurance 100%, right, that it will not go up until your end of your simulation. There might chances that it can go up in the middle also. So we don't know whether it is behaving correctly or not. We were just verifying, we were just written the verification environment, we were checking the outputs, it was coming correctly. So we were thinking like everything was done, but not. We have to check the behavior of our design. So whether it is behaving correctly or not. So whatever the inputs we are giving, whether it was acting according to our inputs or not, or it was changing due to some internal delays or due to some external noises, whether the signal is changing or not, you have to check it. So for that purpose, we'll be writing the assertions. Okay. So it's a verification technique that is embedded in the language. So you will also like assertions are used to check the occurrence of a specific condition or a sequence of events. What are sequence of events? I'll explain you in the few slides, like in next few slides. Okay. And it provides the functional coverage. Functional coverage, it's like it was a separate topic which was like related to the coverage part. I'll explain you then. So basically we'll write to use to validate the behavior of a design. So whether it is performing correctly or not, whether it is working correctly or not. These assertions, how you will write is like, after simulating your environment, verification environment, you will get a waveform. You will observe the waveform. By observing the waveform only, you will be writing your assertions. Okay. There are two types of assertions. What we can write means like two kinds of assertions were there. One are immediate assertions and another one is concurrent assertions. Okay. And these assertions will be written by verification engineer. There'll also be some assertions which were written by the design engineers. Means in the Verilog, they'll be writing that that one will call it as like white box assertions or something like that one. The black box assertions will be written by our verification engineers. Okay. Why? Because see, in design, you may have so many internal signals. All those internal signals will not be visible to our verification engineers. What are the signals only visible to us is like main signals, what are input signals, what are output signals. Internal signals won't be visible to the verification engineers. So the assertions which were written for the internal signals also, was written by the design engineer, whereas only for output signals like the main signals, input signals and output signals for a design, for those signals we'll write assertions, that too by observing our waveform. Once after we created our verification environment, we have included our design to the environment, we have simulated it, we'll get a waveform. So based on the waveform only, by observing the waveform only, we'll be writing our assertions. Clear up to now?
Yes, ma'am.
Anybody having any doubts, you can stop it. You can stop me and you can ask me right there, okay? Because I'll be going a bit speed so that I have to complete this topic in this session only. Okay. So in this assertions, what we were writing, we were having two types of assertions. One, those are immediate assertions and concurrent assertions. Okay. So what does this assertions does? It increase the observability and controllability of a design. Okay. So what is observability? Ability to observe the effects of a specific internal stimulate point within the design. So observe the bug at initially without propagating to the output. So we will be observing our bugs initially only. Controllability, we can control this. Like if, let's say if the signal was out of control, we can take it as under our control by mentioning some assertions and things. Okay, so that was thing. And assertion based verification flow, by writing assertions, what are the benefits you'll gain is like you can find bug faster with assertions, you can find bugs, and we can find more bugs with verification hotspots and reduce simulation cycles. Because if you want to find bugs, you have to run your design so many times. Rather than running so many times, if you just write these assertions, so you can find bugs like at least 40% of bugs can be found by running your assertions. Okay, rather than like that's what reduce simulation cycles. Okay, so coming to the immediate assertions. So immediate assertions, what does it do is like it checks for a condition at current simulation time. It will only check a condition at this time only. At present time only, it will check the condition. After some time, it will not check the condition, or before it, like past conditions, it will not check, future conditions, it will not check. It will only check a condition at the current simulation time. Okay. So it's similar to an if else statement. Okay. So how you will write this immediate assertion is like, so this is your syntax. This label is of your choice. So this is your syntax. This label is of your choice and you have to place colon. Assert, you have to use keyword. So expression, as we already said, immediate assertions check for a condition. So the condition expression, you have to write it here. Okay. And pass statement, else fail statement. So this is the syntax for writing an immediate assertion. It's simple, like simple if else statement, how you will write in the same way, but instead of if, you have to put assert keyword. Okay. And this immediate assertions have to be placed in a procedural block. It means whenever you're writing an immediate assertion, you have to write all your immediate assertions inside an always block only. Okay. Not like in any other things. Only inside an always block, you can write your immediate assertion. Whereas for concurrent assertions, the other type of assertion, there is no need that you have to write it only inside a always block. There's not necessary like that. Okay. For immediate assertion, it was a mandatory thing. Whenever you're using immediate assertions in your design, you have to write inside an always block. Okay. It means like a procedural block, either always block or initial block, both can be used. And how you write this assertions is like you have to take a separate file, and in a module only you can write assertions. Okay, not in a class. In a module you can write these assertions. In that you have to use procedural block, that is either always or initial. Okay, but maximum always only will be using for this immediate assertions. Okay, and no temporal checks. No temporal checks means it the signals, like here we will be writing an expression which is like using signals only. So these signals we are not checking on clock basis. Okay. Behavior of that signal we are not checking on regarding to the or with respect to the clock. So that's why these are called as immediate assertion. So if you are writing always block in the sensitivity list, you can give either start or your input signals. Okay. So how you write a combinational circuit? In that way only you have to write this immediate assertion, means the always block condition you have to write in that way only. Okay. And these like pass statement, fail statement, these are like all optional statements. If you want to keep, you can keep, or if you want to remove also, you can remove it. Those are not mandatory things. Okay. Clear everybody? What are immediate assertions? Anybody having any doubts? So these are different forms of immediate assertion you can go with. Okay. So yeah, so with by using pass and fail statements, so evaluates to true, we were displaying a statement. If it is else, like if this condition fails, we were using another display statement too. Only with pass statement also you can use. So like instead of like in fail statement, instead of using dollar display, you can use dollar fatal also. It's like a fail verbosity. And without using a past statement, you can use only a fail statement also. In this way also you can write. Here you are only with fail statement you are using, that too with dollar warning you are using, and with label also you can use. So in these are the different forms to write an immediate assertion. In all these ways you can write it. Okay. It's not only limited or specified to only one type. So you can write in these many ways. As I already told you, pass and fail statements are not mandatory. So in all these ways, you can write your immediate assertions. Okay. So coming to the severity levels. So here, if you observe in the previous thing, we have used dollar fatal, dollar warning. So what does those means? Here we can get to know. Okay. So assertion is a statement that something must be true. The failure of an assertion shall have a severity associated with it. So if it is true, it was fine. But if your assertion is failing, there will be some severity associated with it. So by default, if you are not mentioning anything, so by default, the severity of an assertion failure is an error. Okay. So it means like a dollar error. Means you will get an error when you are failing or something. Okay. So other severity levels can also be specified, including one of the following severity system task in the fail statement. So in the fail statement, you can use all these system tasks. It's not only limited to only dollar display. For the fail statement, you can use these many things. For runtime fatal error, if you use dollar fatal, it would be like a runtime fatal. If you use dollar error, it's a runtime error. Dollar warning is a runtime warning which can be suppressed in a tool specific manner. So this dollar warning, you can suppress it. Okay. And dollar info, you can also use dollar info, which indicates that assertion failure carries no specific severity. Okay. Dollar info is like, it's just a normal information thing. Okay. So it means like no specific severity will be carrying by that fail statement of an assertion. Okay. So if an assertion fails and no else clause is specified, like if we have seen here, we have used only a pass statement, we have not used any fail statement. So in that scenarios, so we have not mentioned any else clause. So the tool shall by default call dollar error. So by default, it will call dollar error because by default, the severity of an assertion failure is an error. So severity can optionally include further message information using dollar display syntax. So you can also use $display syntax apart from this dollar fatal, dollar error, dollar warning, or dollar info. Okay. Clear up to here? Up to here, it consists of immediate assertions. Where you will be writing this, for which signals you will be writing this immediate assertions is like for your combinational circuits. Mainly for combinational circuits, we'll be using this immediate assertion because immediate assertion doesn't have any temporal checks. Means no checks were associated with the clock. But in real time, I'm not sure like whether we'll be using much, but I haven't used any immediate assertion because in our real time projects or anything, we will be using all sequential circuits only mostly. Means combinational circuits also will use, but the final outcome will be the sequential circuits only. Combinational circuits for building blocks of sequential circuits. So at the end of the day, you will be writing assertions to check your signals with respect to the clock itself. So in that case, you have to go for concurrent assertions. Up to here, clear everybody? What are immediate assertion? Where we have to write it? What is the syntax? What are the severity levels? Everything. Coming to concurrent assertions, this is the main thing where you will be writing because most of your designs will be of sequential circuits only. So concurrent assertions are mostly used. So this concurrent assertions check the sequence of events spread over multiple clock cycles. Whereas in immediate assertion, we have seen that it will check the condition at the current simulation time. Not it will check the conditions for future thing, or in the past thing it will not check the condition. Only for at present current simulation time only the immediate assertion will check the condition. Whereas concurrent assertions is not like that. It can spread over multiple clock cycles. If you want to check the condition over 10 clock cycles or 100 clock cycles, you can check the condition, okay, by writing the concurrent assertion. So the concurrent assertion is evaluated only at the occurrence of a clock tick. So this we were having in concurrent assertions, we were having temporal checks. So it is like behavior is only checked at clock signals. Okay, it was only checked at clock signals, and the test expression is evaluated at clock edges based on the sampled values of the variables involved. So it will only the expression will be evaluated only at this particular passage of a clock or something like that. Okay. And this concurrent assertion can be placed inside a procedural block, means inside an always block you can place it, or inside a module you can place it, or inside an interface, or inside a program block. In all these blocks, you can place your concurrent assertions. Whereas immediate assertions, you have to place it only in a procedural block. The immediate assertions, you can't write it in an interface or program block. Whereas concurrent assertions, you have that flexibility. Okay. So this is the syntax for your concurrent assertions. So C underscore assert is your label of your thing. Assert property. So here you can give like, there are like two ways you can write. Simply here you can give the condition and you can write it in a single line, or otherwise you can write it in other way also. I'll just show you. I think here I haven't mentioned. Yeah. In this way also you can write your concurrent assertion. Okay. Ignore this everything. Just see the example. Okay. So initially you're giving your property name. That in the property name you are writing all your condition, and you are ending this property. This is your label, assert property. Here you are giving your property name. That's it. So in this way also you can write, or simply what is the syntax we were discussing is like your label, assert property. Here only you were giving your entire condition to check it. Okay. So that one thing, in that way also you can write, in this way also you can write. Okay. So here you are writing for at passage of clock. At every passage of clock, your A and B value means like by using a logical AND operation. So A and B you are doing, and the output it's like not of. Means what is the output here? If you are getting 1, it should be 0. You are making it as 0 and you are checking it whether it was working it correctly or not. Okay. So the keyword differentiates the immediate assertion from the concurrent assertion, which is like the property keyword. So only this property keyword will differentiate from the immediate and concurrent assertion, because for both immediate and concurrent, we were using assert keyword. Only the thing is like after assert in immediate assertion, you will be writing a condition, whereas here in concurrent assertion, you will be writing a property keyword. Okay. So here where this point just says like we have seen system Verilog stratified event queue, preponed region, observed region, non-blocking assignment region, active region, reactive region, all these things, right? So where does this assertions will execute? So sampling of variables is done in preponed region. Your assertions will execute in 3 regions. Okay. First of all, sampling of signals will be done in preponed region, and evaluation of expression is done in observed region. The expression evaluation will be done in observed region, and in the reactive region, it will execute whether the expression is pass or fail. The execution of pass or fail statement will be done in reactive region. So it would be an interview question like whenever you were asked like in how many regions assertions were uh, evaluated or something like that. So you can say in 3 regions assertions were evaluated. So sampling of variables is done in preponed, evaluation of expression is done in your observed region, and the pass or fail statement will be done in your reactive region. Okay, and it's a temporal check. So behavior is only checked at clock signals. So concurrent assertion layers. So we were like coming from here. So these are building blocks for a property. Okay. So initially it will be like a Boolean expression. So in the Boolean expressions, you can use expression, function, and anything. So in sequence, you will be having something like repetition throughout with an intersect. I'll let you know what all these things. In sequence, you can use all these things. And in property, you have disable if construct. These are the keywords. Okay, disable if, not, implication, everything. You for some things you will be having symbols, and for some things you will be having a keywords like this. For disable if you are having a keyword, not also you can use as a keyword, and with the symbol also you can use, whereas for implication you have to use a symbol. I'll let you know what are those symbols also. And finally the assert property means assert, cover, bind means like your instantiation of your assertion, because you will be writing in a separate file this assertions. How you are attaching or how you are adding that assertion file to your verification environment, that will be done in your last layer. Okay, so these are your concurrent assertion layers. Clear everybody up to here, like what are concurrent assertions and what are these things? So the first layer in concurrent assertion layers is Boolean expressions. So what does it does is like the functionality, like what are the things you want to write in a Boolean expression. It was like combination of multiple logical events. So like this, it's a combination of multiple logical events. These are all your logical operators and everything. All operators you can use in this. Okay. So these events could be simple Boolean expressions. So and in this Boolean expressions, you can also include function calls. but you are having some restrictions. You can also include function calls, but you are having some restrictions. What are those restrictions? We'll see now. So functions that appear in expression cannot contain output or reference arguments. Means functions like function call, which you are calling inside this Boolean thing. So those should not contain any output argument or reference arguments. Okay. And functions should be automatic and have no side effects. Means you can't call a static function inside a Boolean thing. You can only call an automatic function. Okay. So Boolean layer, this Boolean expressions, it can't use following operator types. So what are these things? Means like data types. It's like short, real, real time, string, event, channel, class, associative arrays, dynamic arrays. All these data types can't be used in your Boolean layer. And operators, all operators you can use, like what are you having? Bitwise operators, logical AND operators, shift operators. You are having so many types. Arithmetic operators, you are having so many types, no? So all operators you can use in your Boolean expression, but except assignment, increment, and decrement operators you can't use in your Boolean expressions or Boolean layer. Okay. Apart from assignment, increment, and decrement operators, every other operator you can use in your Boolean expression. So this is an example for your Boolean layer. Okay. So this is your Boolean expression. So here you have declared variables, and for those variables, you are just declaring your Boolean expression. So these variables, see, it was like only wire type. Here it was not any short, real, or arrays, nothing like that. It was of wire type. And here you have used all the operators. We have not used any assignment, increment, or decrement operators. Okay. So this is the first layer. We have discussed Boolean expression or Boolean layer. And the next layer is sequence layer. In sequence layer, we were having so many things. We'll get to know what are those things we can write in a sequence. Okay. So temporal properties are described using sequences. Means the signals which you want to check by using a clock or with respect to clock can be written inside a sequence. Okay. So how to write a sequence is like sequence and end sequence. In the between of that, you have to write your entire expression. Okay. So Boolean expression events that evaluate over a period of time involving single or multiple clock cycles. So sequence is nothing but series of Boolean equations. So you are writing Boolean equations in a series. So sequence is nothing but series of Boolean equations. These are building blocks for properties. Your sequence and Boolean expressions are building blocks for properties. Okay. So the sequence can be declared in module, interface, program, clocking block, package, everywhere you can declare the sequence or you can write the sequence. And one sequence can call another sequence. So you can call another sequence also. So the list of operators that sequence are built upon is like whenever you are writing an assertion, so the delay, if you want to mention any delay, you should not like use normally in the verification environment or in your Verilog design. For mentioning delays, you will be using a single hash, and later you will be writing your delay number. But here in assertion, if you want to mention a delay, you have to use double hash. Okay. So these are some of the operators. We'll get to know what are those operators. I'll explain you. Okay. So sequence, name of your sequence you have to give. At passage of clock, what are the expression you want to write? So that one you are writing. It means like a double hash one. I'll explain you. Like when the double hash operator comes, I'll explain you. So the expression you are writing and end sequence. Okay. So this way you can write your sequence. Okay. I think it's about to complete. I'll share a new meeting ID. Please join in there. Okay.